Welcome to this Ask the Expert session on Agentic AI on AMD GPUs. My name is Shailen Sobi, and joining me here is also Mahdi Godsi. I'm based in Munich, Germany, and Mahdi.
Hey everybody, this is Maddie. I'm based in San Jose, California. Happy to be part of this talk. Awesome, back to Shailen.
Wonderful. So we are both in the AI developer relations team, and for the next hour or so, everything will be about Agentic AI. So let's dive right in. So the agenda I prepared today is uh, something like that. We will dig into the world of agentic AI. Right now, it's the buzzword, it's the hot topic. So we'll go into what it is and also speak about the great things of doing agentic AI locally. Then we will talk about the AMD agentic AI stack. So here we'll go from the basically from the bottom uh, lowest level, the hardware, all the way to the top where the agentic AI workloads rest. And we'll see at every layer what is there, what's happening. And also in agentic AI, I guess you would like to know some real world use cases. I prepared some for you. And then we'll wrap up with a Q&A session. So agentic AI. I think the best way to look at it is to go right from the basics. At the heart of every agentic AI pipeline slash workflow, you will have a large language model. So actually here, let me turn my pointer so I can use the laser here. So the large language model, that is the way you can look at it is basically the the language engine. Whatever you put in, the tokens in, it will give you tokens out. But at the end of the day, it is just that, right? It just takes tokens in and gives it tokens out. It doesn't do more than that. So um, building on top of that, you need to wrap up more things to make it more useful. So if you look at a chatbot, for instance, you bring in things like sessions, like memory, so that you can build a sequence from your token in, token out engine. Building on top of that, we have now agents. So agents bring the chatbot, the traditional chatbot that you know, to the next level, whereby in an autonomous agent, you have things like planning, like reasoning, and using external third-party tools, for instance, crawling the web, fetching data from database. So this is what these are the basic building blocks what makes agentic AI today. I like to look at this these three boxes here from a bird's eye view, and I found a very nice diagram on the internet. The link, the source of this image is in my endnotes. And I think this image here really explains not only the historical development, starting from LLMs to now agentic AI, uh, but gives a great perspective of what are the various layers. If you look at it as an onion layer, you all know about the LLMs in yellow here. And 4 to 5 years ago, things like DALI and Midjourney and Stable Diffusion made big noise, and that was the generative AI level because it took LLMs to the next level in generative AI. Then came agents. AI agents take generative AI to the next level, whereby now you have things like planning, some reasoning, and also memory is really key, where you build a flow in conversations with your AI. This is, for instance, when you go on ChatGPT, you ask a question and then you come back the next day, it still remembers what you asked before. This is the memory, the session that it saved about what you asked before. And then on top of just AI agents, now we have agentic AI, whereby you have more advanced topics like ability to observe and trace the whole flow, the ability to improve itself as an agent. So this self-improving part is one key aspect of what makes agentic AI great today. Setting a goal to an agentic AI system, like your goal is to build me a whole SaaS system, right? So doing things like that you can do, um, and that's that last layer of that onion um, analogy here. I believe there's also one layer on top which is not in this image, and probably that's physical AI. We need to see and watch how things develop in AI, and the great thing is it's, a it's an always moving engine, this whole AI scheme. All right, so let's dig a little bit deeper in AI agents. I look at it as an agent having three main components. And basically, every AI agent will have these three components. The first component is the model. Technically, that's the tokens in, tokens out engine. And there are various models that you probably are familiar, like Gemma 4 from Google, Qwen, Alibaba, Kimi, Minimax. These are really great, powerful models. And then the second component of an agent is the runtime. The runtime is really important. It is essentially this plumbing that keeps everything running. It can manage the agent loops, the context, understanding what you just asked, and also executing tools. Um, these are the very important parts which will build on the third component of an agent, so the tool calling, and also dealing with failures and so on. And that third component is basically the tools. You can look at tools as basically the hands of the model. So what it can do, crawl the web, fetch data from a database, open a browser, for instance, or automate things in a browser. So this is all about tools, and this is what makes agents so powerful today. Now, agentic AI is powerful, but there is also one really important aspect: is where do you run agentic AI? I think it's really important that you are able to run this locally. And why does local matter? I think there are four great reasons for that. One is data sovereignty. In today's world, data is critical, it's precious, especially in fields like healthcare, finance, or defense, or anywhere where IP is really, really important. You need to really own your data and make sure everything is secure. So data that cannot leave your premise, this is the area, data sovereignty, really important, so run locally. The next is performance. So probably you've seen with Claude, you have cloud APIs and there are rate limits. And if you're sharing GPUs, for instance, you may lead into bottlenecks where you don't have enough availability of the hardware. And this eventually impacts your latency and how fast you get your answers, especially with the free accounts on ChatGPT or Grok and so on. You ask a few questions and it tells you, okay, you have reached your rate, please wait, and so on. So running locally, you will never hit those limits. And also when agents need to talk to each other in real time, there are unpredictable latency that kills the workflow quality. Running locally gives you dedicated hardware with a consistent performance. Finally, cost efficiency. If you're making thousands or millions of inference calls per month, the per token API pricing can really add up super, super, super fast. Maybe on LinkedIn or on other social media, you've seen posts like my monthly budget reached $300,000 on API calls. So this can happen. However, if you own your local hardware, well, your capital, your costs, these are fixed and they are amortized over time. So the economics really flip on your side as you scale. Then full customization, really key aspect. You have the full ability to choose your model. You have your full control on fine-tuning your model that you picked for your own domain. Let's say you're in healthcare, you can have your own health fine-tuned model that runs for you. So you're not locked into some third-party model that you cannot change, right? You can even decide on how you want to quantize your model, make it run faster, things like that. So basically, you have all abilities and choice. And that also means no vendor constraints. Therefore, running locally is great. You can do this on your own laptop if you have a Ryzen AI machine with lots of memory. You can run it on workstation class GPUs like the Radeon GPUs, or the big, large data center GPUs, essentially the Instinct lineup of GPUs. And we'll talk more about the Instinct GPUs later in the deck today. Let's have a look now at the Agentic AI stack. So here we'll talk about the hardware and the software and talk from a bottom-up approach. The whole stack looks like this. Hardware down below, these are the GPUs. These are the heavy house, big, powerful GPUs that eat tokens for breakfast. We have the MI300X, MI300 325 and 350 series, and we'll dig a little bit deeper shortly. Then on top, what makes the hardware available to the software at a higher level, this is the ROCm stack. This is AMD built, lots of components in there, including compilers, debuggers, libraries, and so on. We'll go into details there as well. Then very important, the inference engine. This is what exposes a model that you've picked to an agentic framework that is on top. So at this layer, you have multiple choices. VLLM is probably one of the most popular ones out there. There's SGLang, Olama, Lemonade as well. And then here, Atom, this is an AMD built plugin. It basically stands for ITER Optimized Model, and ITER spelled AITER, which itself stands for AI Tensor Engine. This is a great plugin that AMD developed that makes VLLM even more powerful. I have a slide on this to go deeper there, and I strongly recommend you, if you have not yet looked at it, to have a look at Atom. Now, serving a model, you will basically be exposing an OpenAI compatible API that speaks JSON language, and then your AI frameworks on top will be consuming the model served through this API. Very popular frameworks out there are OpenClaw, Hermes Agent, there's Crow AI, LangGraph, Google ADK, and so on. All of these are agentic frameworks. And I tend to look at OpenClaw and Hermes Agent as being more than just frameworks, but rather agentic AI harnesses. They're extremely powerful. I've been using both quite extensively, and I love them. So today's talk will revolve around these two. A bit more about the hardware level down below. We have the AMD Instinct GPUs for AI. And our current available flagship GPUs are these lineup here. So MI300X based on the CDNA-free architecture. This GPU is really great. It comes with a whopping 192 gig of HBM3 memory. So that's a lot. You could fit a lot of models there, or you could have one huge model serving a lot of requests at a time. So having such huge VRAM is great. Also, lots of bandwidth. As you know, in LLMs, you have the prefill stage and the decode stage, and the decode part is the memory bandwidth part. And decoding is basically when the tokens are being printed, right? So the higher the bandwidth, the faster it is for the decode phase of the LLM. And these GPUs have huge bandwidth. The next generations, even higher bandwidth, even larger memory. This is amazing. Um, and then the MI350X, which has the CDNA4 architecture, even larger VRAM, so more models and much higher bandwidth. So the GPU lineup today are extremely excellent. Now, looking a little bit at the chip, how that looks like, this is just one of those MI300X chips. And on one node, you will basically have 8 of them. For those who have never seen a GPU node, it basically looks like this. We call it a platform. A platform has 8 GPUs. What you see here are basically 8 of them. And those big boxes, that's the cooling on top of that chip that you saw on the earlier slide. So this is how one node looks like. And now this is extremely powerful. Like all of these 8 GPUs give you in total 1.5 terabyte of HBM3 memory, and in total close to 900 gigabyte per second of bandwidth. So this is a beast. Now thinking at the rack level, you can have multiple nodes building more GPUs if you ever need it. Yeah. So powering all of this hardware is the ROCm stack, and that's a kind of a bird's eye view of the whole ROCm stack, what is in there. I will just spend a few minutes on the key parts. As an AI developer, you guys are here. You are at the ecosystem level. You're using open source tools, PyTorch, TensorFlow, even your AI harnesses like OpenClaw and Hermes Agent. They're all at the ecosystem level. They leverage the ROCm stack in order to make the most of the GPUs. In there, you have things that make all of that possible. These components are really useful. For instance, if you want to understand how your AI workload is behaving on the hardware, we have profilers. For instance, ROCprof will be one of the profiler part of the ROCm stack. Debuggers as well. Of course, if you do HPC, if at all, we have the Hipify tool for converting CUDA code into HIP code, and so on and so forth. So this ROCm stack is really comprehensive, gives you all the basic building blocks to do AI efficiently. You may also be a person that enjoys tuning gem kernels, if that is one thing that you do. So you have the libraries and the gem building blocks all provided here. And of course, RICL for scaling out on multiple GPUs, scale up and scale out. I spoke earlier about VLLM Atom. That is this plugin, basically the middle layer between VLLM, the serving engine, and the hardware. And I have put the link down below on GitHub so you can read more about it and try it. What is part of Atom is basically AMD optimized special attention engines that really make AI models much faster. one of the key goals of having Atom as a plugin here is we have a test bed where we try to make models really, really fast and eventually push into the public VLLM core. This is really a plugin. It doesn't modify the core. And all the good things that we do at the Atom plugin level, they get upstreamed eventually into the VLLM core. So you can expect all the latest breaking technologies from AMD being developed here. So if you want to live on the bleeding edge, you need the Atom plugin. Now, bleeding edge, a key thing is about model support. AMD is at the forefront of supporting any new models coming out there, and we are very proud that we offer day zero model support for almost all the great key models. For instance, Minimax from Minimax AI. The day it appeared, it ran on day zero on AMD hardware. Same for DeepSeek, Qwen, Google Gemma 4, Kimi K2 from Moonshot, as well as Mistral AI models. So here are some examples. This is really to show how proactive AMD is at making sure that all the latest and greatest models run from day zero on AMD hardware. Now let's talk about the agentic AI side of things and the two popular agentic quote-unquote harnesses. OpenClaw and Hermes Agent are by far right now the most popular open source agentic AI tools out there. I think, yeah, from looking at the GitHub stars, you can have an idea how popular it is. The number of stars shooting crazily like an exponential graph. Right now, OpenClaw has over 250,000 stars, and Hermes Agent catching up with over 170,000 last time I checked. So this is huge, and the adoption rate is really, really, really large. So we make sure that these two frameworks or agentic AI harnesses run very well on AMD hardware. And today we're going through some of the use cases of OpenClaw and Hermes Agent. Some key points about these two. OpenClaw being a gateway first, basically what that means is it's a persistent agent runtime. It's not just a framework that you import, but it's always running on your system. It handles multi-agent orchestration at scale. It supports the tooling aspect through MCP calls and expansive integration into various tools like Slack, Discord, and so on. So this very, very expansive tool integration there. And you can, because it's a gateway first, you can have proactive agents that are always on and they respond to events happening. You can connect it to your phone through Telegram, WhatsApp, and so on, and they wake up whenever you call them. So this is great. Basically, from a high level, these two harnesses, they are fairly similar in how they work. Hermes Agent differentiates a little bit by being agent first and really acting as a personal AI assistant. Of course, OpenClaw can also be a personal AI assistant, but Hermes was built first to be that personal AI assistant. And what is quite nice with it is it's auto improving skills. For instance, when it makes mistakes by default, this is a feature built in Hermes Agent. It improves itself, learns over time, and gets better by itself over time. So these are the two very powerful tools out there. So now let's look at some use cases. I prepared one use case of agentic AI. Um, for example, you could have multiple sources of data being fed into a system. You can have PDFs, documents, lots of spreadsheets and CSVs, maybe images and scanned documents, emails and communications, various data types of input documents and data. And what you can then have is multiple agents that are specialized in treating those types of inputs. So you can have a special agent that is really good at parsing and doing OCR, so optical character recognition. So if you have PDFs, you may need that. For images, you may need OCR. So you can have an agent that's dedicated, that's powered by an OCR strong model, and it does data extraction really well. For spreadsheets, that's pure data, numbers and text, right? You can have another agent that does reading text really well, finding patterns in data, and so on. So then it's a dedicated agent. Um, Emails and communication, you could have another uh, agent that has maybe human style of communication that writes email outputs, which an OCR model may not have, right? So the nature of models may differ based on what is being input to the system. So here you can see multi-agent kind of scenario. And then outputs can be also multiple different types. Structured JSON, database records, can be also charts and analytics dashboards, can be compliance reports. This here in a compliance report, for instance, you may want to have a human level writing type of model or agent doing that, right? So it is very diverse, this whole scenario, diverse inputs, diverse types of agents, and diverse types of outputs. So that's one use case where agentic AI would come into play, where you have a multi-agent scenario. One other use case, this one was, I developed this with OpenClaw. It is a multi-agent real-world use case. I find it really interesting because it was trying to solve one problem that I have myself. I attend conferences and I go into multiple talks, and all I do is take a lot of pictures of the slides. And then at the end of the day of this conference, I come back home with 100, 200 pictures. And the problem is I never look at those pictures again. And and I guess a lot of people attending conferences may have a similar problem like that. So I designed a multi-agent system in OpenClaw whereby I would input all these various images from my conferences and have OpenClaw draft me a report, a summary of all the pictures that I took, so that later I can just skim the document and remember um, what I attended. And it could also be your boss is asking you, hey, what did you learn at this conference, right? So now you have all the pictures and you have a report out of it, which is great. And what is nice out of it is I had this transcriber agent that was powered by a multimodal Google Gemma 4 model, which is really good at reading pictures and extracting information. And then it's able to then also stitch together a storyline from image one to image two, not that it gets one piece of text from one image and then another piece of text from the other one and doesn't link them together. So Google Gemma 4 did a great job at transcribing the images. And then I had a second agent called the report generator that put all of that in a cohesive human-like piece of report. You could feed in a template, like for instance, if it's a high boss asking you some details, you could have like an executive summary, just a few lines, or if it's for someone else with details and you want pictures also in your report, you could feed in various types of templates and you get your report the way you want. So that use case, I've been using this multiple times and I love it. It's a very simple use case, just two agents, but you can see the powers of OpenClaw in this case. Now, you can see here two agents. So two agents doing very specialized things. The transcriber agent needed a very good image-based model. So Gemma 4 was one of them. A report generator, all I need is text. So I don't need a big, heavy multimodal agent to do that. I could power my report generator agent with a smaller model that all it does is write good human-like reports, right? So two agents, two different models. How would you then do that in a real world? I think that a tool like this, the VLLM semantic router, could be extremely useful into solving this multi-agent, multi-model problem. For instance, you have one type of content, review this PR. It will need a dedicated model that is really good at PRs. Summarize this report, you need a model that's very good at summarizing. Analyze PDFs and blueprints, and like this are the example I talked about. So you need another model for good vision, OCR, reasoning, and so on, right? So you get the idea. Different types of requests coming in, and you want to have your system very efficient. So use the right model for the right task. By doing that, you kind of optimize your workflow. The right model for the right task will give you the greatest quality of content, also at the speed required, right? So for instance, if I say summarize a piece of text and I'm spawning a super huge, massive 100 billion model to summarize a text, it will take me a long time. It's not efficient, right? So the VLLM semantic router comes into play by understanding the incoming requests and then semantically splitting that and allocating the request to various models that it has in its model pool. So here, this slide summarizes that. An input about coding, review this PR. So this is coding and analysis. Qwen 3.5 is a really great model for doing coding. Vision, Gemma 4, for instance, would be great at doing that. So yeah, you could have the VLLM semantic router sitting on top of OpenClaw, such that OpenClaw or Hermes agent then picks the right model for the right input. So I think this is a great use case of using multiple open source tools for best performance and experience. Now, serving multi-model on AMD, this is extremely possible. You could have, for instance, this node where you had 8 GPUs. You could pin a certain model to a specific GPU. This is also possible. So this is scaling out. RayServe and VLLM will be able to allow you to use a multi-node, multi-GPU scenario. And you could have a dedicated GPU be reserved for a specific type of use case. Of course, you're going to be using multiple GPUs as a company, as an enterprise. You're scaling your agentic AI use cases. All right. So that being said, where do we start? There are multiple avenues to get started. For today, we'll be talking about the AMD Developer Program, where you will get access to the AMD Developer Cloud. So those great GPUs I talked earlier, like the MI300X, the MI325 and 350, these are available on the AMD Developer Cloud. I'll show you that in a bit. And then on the developer program, we have access to training resources. These are great material to get started with Agentic AI. So let's dig into more details. As a quick start, you can always develop locally on your local laptop. You have, let's say you have a Ryzen AI machine with lots of memory. Great, you can spawn a model served by Olama, and there you go. You can connect OpenClaw slash MS Agent to Olama, and there you go. You can use it locally as a quick start. As you grow and go into production, you would need something more powerful. And there you may want to look at VLLM, which we talked about, or scaling on multiple GPUs with RayServe. So there you will need probably also those powerful MI300X or MI350X GPUs. So this is really going big. And for enterprise, we also have the AIMS. So the inference microservices built by AMD. This is what it stands for, AIM. We have those prepackaged microservices that come with everything that you need to deploy inference at scale. You can fine tune with the AI workbench. You can containerize with Kubernetes, monitor, and basically have the full stack of understanding where your containers, how they are used, and so on. So basically, from the smallest hardware, the client edge device, all the way to the cloud slash in the enterprise, we have the tools, the right hardware for that. We spoke about the AMD Developer Program earlier. I have put a big QR code here. That's basically this link here. Since you cannot click that URL, you could, with your phone, scan this. It's going to lead you directly to the AMD AI Developer Program. This is a great place to get started because there are really great member perks, which I will talk about in a bit. Who should join the AMD Developer Program? Basically, that's you. If you're listening to me today, you're probably one of these people in those three baskets here: AI researchers, ML engineers, or students. So if you're researching, you want to run experiments today, you want to validate, through the AMD Developer Program, you will have access to the AMD Developer Cloud, where you get the MI300X GPUs. And yeah, as from day one, signing up, you get access. You can try already your experiments. Machine learning, data scientists, AI, deep learning engineers, you have developed something, you want to benchmark that today, go ahead, you have the GPUs right there, and you can compare and see how your workload is performing. You could have your agentic harness, OpenClaw, Hermes agent already running in that system. It's essentially a complete VM that we give you, and you can do whatever you want there. Install Hermes, install OpenClaw. Your data is there, and it's kind of secluded. And like we said, right, data sovereignty. You own that data there, and do exactly whatever you want. Student and open source software contributors. Of course, all the software stack that we provide is open source. AMD is one of those companies that really love open source. Everything that we do is open source. From our whole ROCm stack, every component out there is open. So we welcome people also to contribute to our stack. Now, what are the benefits of joining the AMD developer program? First of all, the cloud credits. The cloud credits translate into, read it as free GPU, free compute for running your AI workloads and your agentic AI use cases. So you will get $100 in credits. If you manage your VM efficiently, you will get a lot of hours of compute. You also have the ability to get Fireworks AI API. So that's just an API to a Fireworks endpoint, and the hardware lives on Fireworks data centers in OpenClaw/Hermes agent. While choosing, your model endpoint, you have an entry Fireworks AI. This is where you can put your API token that you get from us. So this is really great. Free compute, read it this way. Then expert access. This is where people like us, Madi and I, and many of our colleagues are accessible. On Discord, you could ask your questions, and there are experts answering them. It can happen, you're trying something, you try something with ROCm, you have an issue, you want to get answers very quickly. So that private Discord, being a member, gives you access to getting the answers really quickly. So this is really great. We also have the monthly office hours where AMD engineers are there answering your questions. We have AMA, so Ask Me Anything sessions, like this one, for instance. So you have those monthly events, and of course, being a member, you get to know about that. Then the premium training. On the AMD Developer Program, you have access to the AI Academy, and on that AI Academy, you have tons of training material for all levels, beginner, intermediate, advanced. And these are extremely great resources to get up and running very quickly. All the links are part of that developer program link that you saw earlier from that my QR code. And on top of that, you have 1 month of deep learning AI Pro. So this is a usually paid membership, but through the AMD developer program, you get 1 month of access for free. Now, if you are not boosted already by those free starting great number perks, there's a fourth one even. You could compete on the developer program and earn points. And there are monthly sweepstakes where you can win a GPU or a Ryzen AI PC. So, of course, this comes with learning, completing the courses, winning points. And the more points you have, the more the chance of being part of this monthly sweepstake. Now, just a caveat, I don't know my audience right now, but if you're part of the US and Canada region, you're eligible for that. All right, so the cloud credits, I talked about that. That's those $100 of GPU credits. That's the VM. You can do whatever you want there. And the $50 of Fireworks API, if you installed, for instance, Hermes agent or OpenClaw locally on your system, or let's say Windows subsystem Linux, then all you need is an API, right? So there you can use Fireworks AI. A few more details about this premium AI training. These are all self-paced content, spawning from everything from that ROCm stack, right? So you can learn everything from deploying AI agents to learning how to tune gem kernels. These are really well written Jupyter notebooks that walk you end to end through learning. I made a screenshot here, AI agents. For instance, this one was built by Madi, who is here in the call. The second one I built, it's based on Google ADK, where I show you how to design a multi-agent scenario with Google ADK, ADK standing for Agent Developer Kit. Great tutorials. I made a screenshot of 2. There are tons more. So really, go ahead, click that link, sign up, and enjoy those great training courses. Then, of course, the deep learning AI from Andrew Ning. All right, so that wraps up the Agentic AI topic of today. There are some key takeaways for you. AMD Instinct GPUs, tons of memory, really great for tons of models for your agentic AI scenario. We talked about VLLM, we talked about VLLM semantic router, multi-agents and multimodal scenarios. So lots of RAM really answers the question of multimodal and multi-agent scenarios. Full stack is open source. We love it. AMD loves this open source. We contribute a lot there. So ROCm, VLLM, this is third party and open source. Hermes agent, OpenClaw, all of these are open source. We don't deal with vendor lock-ins here. So yeah, that's a key takeaway. Multi-agent workflows run today on AMD. You can try it out on the AMD Developer Cloud. You can also try the different multimodal approach, and a model can be also multimodal, dealing with vision, dealing with text, and so on. So all of that is possible. Local AI, very important. You own your data. You do whatever you want with it. You can handhold, or rather control how much performance you want because you own the hardware, and you're also not impacted by rate limits and so on. So that's a great thing of having a local AI. And then finally, the AMD Developer Program and the AMD Developer Cloud. So access to the GPUs, you will get that once you sign up to the AMD Developer Program. The link, you had it before. So now we open the floor for some Q&A, and I will take them. Let me see.
I think there's some questions that I see right now. One of them is about any thoughts on what the performance difference might be between using Lambda CPP and VLM plus Atom. I'd love to get my model running faster on my Strix Halo system. I guess, a quick answer. I personally don't do a lot with the Strix Halo, but I work closely with a team that have developed Lemonade. In the backend, yes, it will use Llama CPP, Vulkan, and whatever is the fastest for a Strix Halo. But I do recommend trying Lemonade if you haven't. I know the team is really focused on making sure that we have the fastest backend for each model. For the VLM plus Atom, I think that as of right now, the current focus is on data center GPUs, such as MI300, MI355, and so on. So you might not get the sort of performance boost that we're talking about on a Strix Halo with VLM plus Atom.
I'll take the second question. A person named Data Scientist asked, when will the MI300X GPU become available again on DigitalOcean? So DigitalOcean, that's the backend of the AMD Developer Cloud, just for your information. So Data Scientists ask, when will those MI300X GPUs become available on DO? And do you recommend using the DO image for hosting Qwen 3.6 models? Example, the VLLM/ROCm images, or just pulling the latest Docker? Great question, Data Scientist. So the short answer, right now you do have access to MI300X. So if you go there, you click on Create GPU Droplet, you should be able to see MI300X. If you don't see it, then it's a bug, it's a problem, but they are available. Some are available again, they are available today. And to the second part of your question, do you recommend hosting Quen 3.6? Yes, Quen 3.6 is a 35B billion, so you could translate roughly 35B will consume 35 GB of VRAM, just the model weights, right? If it's an FP16. So the MI300X has 192 gig of VRAM. So you have a lot of space for that one model. You could even host two VLLM instances, two such models if you want. So yes, you could do that. Just pay attention though. From experience, you may want to tune your VLLM commands so that serving the model for agentic workflows is efficient. So if you just serve the engine without, tuning your max token lane, so that's the name of this flag. So if you put a too huge one, then of course you're impacting your pre-fill time. So you may want to tune these parameters. Tools as well, which tool parser that you're using, pick the right one such that you're using an efficient tooling mechanism and so on, right? So also extending on what data scientists asked, do you recommend using the latest Docker? Yes, you go ahead. You are welcome to using the latest Docker. Currently, what you have there is it tried and tested, and it works. So we know you do VLLM serve, your model will be up and running, but of course, the latest Docker will work as well.
Add something to this answer. Sorry, Shaylin. So, like 2 points I wanted to add. One is, if you ever had the experience of going on AMD Developer Cloud and you saw maybe the MI300 is not available, or it says something like currently no GPU available in your region. There is a limit. We don't have unlimited GPUs. There's we have a lot of them, but the availability is in a general pool. So there is times that, say, if you're trying to access the GPU, you don't have one right now, and it's during a big hackathon that AMD also is leveraging the same public pool, so people sign up for the same thing that you've done, and they're trying to use AMD GPU. So those are the peak times for us, and maybe within that week, you're not going to be able to see one all the time. If you check regularly, you might see that somebody's credit ends and it becomes available. But I feel like if you had that experience, probably been at the time that we were at the peak of what was available. That being said, I think throughout the year, most of the time it's available. It's just those maybe one week that is very competitive to get one. So double check that again. And if you had credits that in any case that was expired, request for more credit, we'll grant more credit for you guys. And about that question that Shaylin just answered about the images, if you're using VLM, just make sure that starting this year in January, we have upstreamed with VLM. So there's CI/CD integrated VLM. So I do not recommend using any forks. Just make sure if you go vlm.ai, you should see a table where you actually have the ROCm as an option. You can select it. You can use the official VLM upstream image for ROCm. So that is what I recommend for using for serving any VLM models.
There's a question on Ryzen AI, XDNA2, NPU support. I'm afraid I may not have the full answer to that. I know there is an open request on the GGML org on GitHub for that, which is still open and not closed. So I think it's not there yet. Details on that, the client team would better answer this. I personally don't know. That was 14N asking about support for XDNA2 NPU in GGML and Llama.cpp. I'll take that next question. Dub Step at a Time asks, so agentic AI can make mistakes. Let's say if I deploy a serverless agentic AI model for a company's workflow, legally and financially, would I be held responsible? All right, so that's a great question. It's touching on responsible AI and laws and so on. I think it's a gray zone, gray line, and it's a bit also tricky to quote me on this one. So a legal person might best answer this properly. There, you know for sure that you're getting the right answer. So we are engineers. I believe basically everything that you're outputting, it's good to tell that it's an AI output. This is how Google with Nano Banana protects itself with all images being watermarked with the made with AI or the little Gemini symbol, so that people know these are AI images. So yeah, Mari, you want to add something on that one?
I mean, I think there's two ways to figure that out. One is if you work for a company and these are questions that you actually have, then one way is you to reach out to your legal team and finance team and just share the risks available, and they probably be able to advise you. Second way is don't, and just send it and then deal with the consequences. I think there's two ways to figure it out. But honestly, we are not at the point that we should give you any sort of legal advice on these models. All have their own license in terms of what you can use or not. But your company should definitely have some sort of legal or finance policies in these sort of things. But overall, I think getting your agent to do something deterministic, if you don't mix it in a hybrid way of mixing code with your agent's decision, it is pretty risky. So even for the things that are not risky, when I use an AI agent, I actually have some codes to kind of like try to verify stuff, but I don't leave the final decision making, especially touches financial stuff, to an agent by itself as of right now.
There's one question from Tasky666. Not directly a developer question, but are there any news regarding PyTorch wheels against ROCm 7.2.4 on Fedora? Sadly, still struggle with RDNA4 in some scenarios. Okay, since you mentioned RDNA4, might be one of those latest GPUs. Yeah, so I checked the latest is still is on ROCm 7.2. Exactly which problem and struggle you have with RDNA4, if you are on Discord as part of being a member, you may wish to post your problems there. And our key engineers working in RDNA and ROCm would be answering and assisting you there. If it's a bug, maybe it's a ROCm issue, maybe it's the GPU not being recognized properly. I don't know. I don't know your problem, your struggle. So I think Discord would be one approach to raise that technical question. Yeah, so the R9700, Tasky mentioned or stated it's the R9700. Yeah, so that's our DNA4. I think please ask that question. Let us know your specific issue on Discord.
I would say also feel free to raise an issue on PyTorch GitHub directly. So there's people that definitely look into that.
All right, so if there are no more questions, we can wrap it up. Thank you everyone for your attention and speak soon.